China already leads the world in solar energy production here on Earth. But now, they're aiming even higher, literally, with ambitious plans to dominate space-based solar power too. This ambitious project is being compared to China's colossal Three Gorges Dam, only this one floats in space in geostationary orbit. It's designed to continuously collect solar energy. No clouds, no nightfall, just pure sunlight all the time. Here's the genius part. The station doesn't store electricity up there. Instead, it beams the energy down to Earth using microwave technology, where ground stations catch it and convert it into usable power. No wires, just wireless energy from space. On Earth, solar panels only work when the sun's out, and even then, weather can mess it up. But in space, there's no atmosphere, no night, just consistent, blazing sunshine. That makes this space farm potentially 10 times more efficient than what we've got on the ground. To handle the heat in space, Chinese engineers designed a cooling system inspired by butterfly wings. Yep, butterflies. And getting the massive components up there? That'll take Long March 9 rockets, which are still in development, but expected to be powerful enough to haul the gear into orbit. This single station could generate in 1 year the equivalent of all the remaining extractable oil on Earth. Let that sink in. If it works, it could massively reduce our dependence on fossil fuels and give humanity a real shot at clean, constant power forever. This isn't just a tech milestone, it's a geopolitical one. If China succeeds, it could trigger a global rush into space-based solar. Other countries might scramble to launch their own power stations. We could be looking at the beginning of a new space race for energy. While China may be leading the charge with its kilometer-wide solar station, they're not alone. Several countries and organizations have quietly, and sometimes not so quietly, been developing space-based solar power tech for years. Let's break down what the rest of the world is doing and how serious this space energy race is getting. The US military and NASA have shown strong interest in SBSP for decades. Right now, DARPA, the same agency that brought you the internet, is working on something called space-based solar power incremental demonstrations and research. This project is testing the tech needed to convert solar energy in orbit into microwaves and then beam it back down to Earth. The US Air Force has already launched experimental solar panels into orbit as part of the X-37B spaceplane mission. Their ultimate goal? Energy on demand for military bases and disaster zones, without relying on local power grids or fuel shipments. Another country is Japan. Japan's space agency, JAXA, has arguably been one of the earliest and most consistent advocates of SBSP. They've been working on wireless power transmission since the early 2000s and successfully demonstrated microwave power beaming over 50 meters back in 2015. Their long-term vision? Launch a solar power station in orbit by the 2030s that beams down energy to floating ocean-based receivers. It's futuristic, yes, but Japan is deadly serious about clean energy, especially after the 2011 Fukushima disaster. They see space-based solar power as a way to secure reliable, disaster-proof electricity. In 2022, the European Space Agency officially launched the Solaris Initiative, a massive research program exploring the viability of space-based solar power for Europe. They're investing millions into studying whether it's technically and economically feasible to build large-scale orbiting solar stations by the 2040s. With energy security now a critical issue in Europe, especially after recent geopolitical events, ESA sees space-based solar power as a potential long-term solution to reduce dependence on fossil fuel imports. India's space agency, ISRO, has expressed interest in SBSP, though more quietly than others. They have published white papers on the concept and held talks with international partners, especially Japan, on collaborating in future space solar efforts. Given India's rapidly growing energy needs and ambitious renewable targets, it's only a matter of time before they jump into the game with a full-scale project. Let's not forget the private players. Companies like Northrop Grumman, Caltech's SSPP, Space Solar Power Project, and even Blue Origin have expressed interest in commercializing SBSP. In 2023, Caltech successfully launched a prototype satellite, which demonstrated power transmission in space and beamed a small amount of energy to Earth. It was a tiny amount, enough to power a light bulb, but it proved the concept. Just a few years ago, space solar power sounded like pure science fiction. Now, it's being tested, funded, launched, and built. What we're seeing is the beginning of a global energy revolution, and space is the new battleground. Whether it's for powering cities or securing energy for remote outposts, one thing's clear. Whoever wins the space energy race could control the future of power on Earth. China is leading in terrestrial solar energy and is the most advanced in scaling up space-based solar power, though the US and EU still have the scientific and technical capability to compete if policy and funding align. Safe, wireless, 360-degree energy transmission is a game-changer and demonstrates China's leading position in this new energy revolution, quite literally harnessing the power of space to benefit life on Earth. Space-based solar power is often criticized as a potential waste of money due to its high cost, technical complexity, and long development timeline. Launching large solar arrays into orbit, maintaining them, and transmitting energy back to Earth, typically via microwaves or lasers, requires advanced technology and massive investments, often in the billions. Critics argue that terrestrial solar power is already cheaper, faster to deploy, and improving rapidly with storage and smart grid technologies. However, supporters counter that space-based solar power offers unique advantages. It can collect solar energy 24/7 without weather or nighttime interruptions, and could be critical for powering remote areas, military outposts, or even space missions. While it may not yet be cost-effective, many believe it's a long-term strategic investment, not just in clean energy, but in space infrastructure and energy security. Whether it's a waste of money or a visionary leap forward depends on how technological breakthroughs and geopolitical priorities unfold over the next decade.